Hey everybody, welcome back to your regularly scheduled programming. Today we are solving LeetCode 169, which is called majority element. The question states, given an array nums of size n, return the majority element. The majority element is the element that appears more than n over 2 times, where n is the size of the array. You may assume that the majority element always exists in the array. Let's jump right into it and solve these problems. Keep in mind that this solution is O of n time complexity and O of n space complexity. And the follow-up to this question is, could you solve the problem in linear time and in O of 1 space, which I'll be discussing after this. Alright, so let's start off with the first one with n equals 3. We have 3 elements. The first step we're going to do is we're going to iterate through this array and we're going to map out the elements. So let's start off with the 3. The 3 is going to be the key, and the values are going to be the occurrences. So far we've seen 3 once. Next element in the array is 2. We'll set that as the key, and its occurrence is once, we've just seen it once. Finally, we're at 3 at the last element in the array, this last 3, and we already have the key set up, so we're just going to increment it, and now we have 2 occurrences of 3. Now that we've finished that, we can calculate a majority target. That's going to dictate whether we pick the right element. So this majority target is just going to be simply n over 2. N is going to be the size of the array. It's n equals 3. So we just do 3 over 2, and that's 1.5. So as long as we find something in our map that has a greater frequency than 1.5, that's going to be our majority element. So now the next step is to iterate through the array, through the map we've set up, and check whether its value is greater than the majority target. So right away we see that 2 is greater than the majority target of 1.5, so we can just return 3. And that is the correct answer because this is the majority element in this case. Let's do this bottom example with a bit more, with a few more numbers. So first step again is to iterate through the array and map it out. So set up 2 as the key, and so far we have 1 occurrence. Next element in the array is another 2, so we're just going to do that. I think you get the gist of this by now, so I'm just going to write out exactly how many elements of each there are. So we have 4 2s and we have 3 1s. The key is the actual element, and the value is the occurrences. 4 2s, 3 1s. Awesome. Now we're going to calculate our majority target, which is n over 2. Our n is 7. That's how many elements we have in the array. And our result for the majority target is 3.5. Now we're going to iterate through our map. We're going to check if any of the values in here are greater than 3.5. If they are, we'll return the key for that. First value in our map is this 4. That's greater than 3.5. So we don't even have to check this technically. But if you want to, this 3 is not greater than 3.5, so we wouldn't return that in any case. So this 4 is the correct majority target, and our key for that is 2. So we'll just return 2. And that is the correct number because we have 4 2s occurring in this nums array and 3 1s. Great. Here is the code to our map solution. We'll initialize a majority target that's going to be the length of the array divided by 2. So whatever element appears more than this majority target is going to be the majority element. We'll also initialize our map. We're going to iterate through the array inside of this for loop, and we're going to map out our elements. We'll set the current element as the nums array at this index I, and we're going to check if the map is already initialized this current element, then we're just going to increment it at that stage. Otherwise, it hasn't yet been initialized in the map, so we're going to initialize it, and we're going to set the value equal to 1. The next for loop is going to be iterating through our object or map, and we're going to be checking if the value in here is greater than or equal to the majority target. If any of the values in there are greater than or equal to the majority target, we'll just return the key for that entry. Let me run this. We've passed our test cases, now I'm going to submit it. Awesome. So on LeetCode, we are given a follow-up of could you solve the problem in linear time and in O of 1 space? And we can do that using the Boyer-Moore majority vote algorithm. The steps to this are as follows. So first, we're going to initialize a candidate and a counter. Those are just going to be variables. Next, we'll iterate through the array and check the following clauses. If the counter is 0, we'll set the current element as the candidate and we're going to increment the counter. If the current element is the same as the candidate, we're going to increment the counter. And if the current element is different from the candidate, we're going to decrement the counter. By the time we're done iterating through this array, the candidate should hold a potential majority element. Finally, we can iterate through the array again to count the occurrences of the candidate and validate if it's the majority element. And it's the majority element if it appears more than n over 2 times, where n is the length of the array, so that just means if it appears more than half the time. I've made a note here in red, which is we can skip this step and actually return the candidate right after we've finished iterating through the array, because we're told the majority element always exists, so we don't really need to validate it. This could prove useful if there was other cases that existed, but like I mentioned, since we're told the majority element always exists, we can just return that right away, because by the time we finish iterating through the array, that candidate will be the majority element. In the code, I'll have omitted this step, but I'll add this validation on the whiteboard just so we have a better understanding of it. I have a couple of examples set up here. Let's start off with the top one. I have a nums array of 3 elements. The index for each element is written above it in red. Let's start off with initializing our candidate and our counter. My candidate is set to null and my count is set to 0. Let's start off with the first element at I equals 0, so that's 3. The first case is going to be struck when we start this. So if the counter is 0, which it is, right, that's what we initialized it to, we're going to set the current element as the candidate and we're going to increment the counter. So I set the candidate as the current element, which is 3, and I've incremented the counter by 1. It was 0 and now it's 1. Next, now we're going to go to the next element in the array, which is at index 1. We're going to check the element is 2 now, and this last case is going to be hit. If the current element is different from the candidate, we're going to decrement the counter. Well, 2 is different from 3, so let's decrement the counter. It was 1, now we're going to set it back to 0. We just subtract 1. Move to the next element in the array, we're at 3 now, at index 2. Again, the first case is going to be struck, where if the counter is 0, we're going to set the current element as the candidate, and we're going to increment the counter. So we'll set the candidate as 3 again, because that's where the current element, and we're going to increment our counter by 1, and it's 1. So we know that, even just looking at this, that the majority element in this nums array is 3, right? 3 occurs more than n over 2 times. In this case, n over 2 is 3 over 2, and that's 1.5, and so we need to have the candidate appearing more than 1.5 times. You can round it up and make it greater than or equal to 2 times, but that's the gist of it. So we can just return the candidate is equal to 3 at that point. Let's go over the next example. This time we have 7 elements, and we'll just run through the exact same process again. Let's initialize our candidate null to null and our counter to 0. Start off with the first element at I equals 0. The first case is going to be hit with the counter. If the counter is 0, we'll set the current element as the candidate and increment the counter. Candidate is set to 2, which is the current element, and then we're going to increment our counter by 1. It's at 1. We move on to the next element in the array at I equals 1. It's 2. This case is struck. If the current element is the same as the candidate, we're going to increment the counter. So 2 is the same as the previous element, which is a candidate, so we're going to just increment the counter, and now our count equals 2. Moving on to I equals 2, our current element is now 1, so the last case is going to be struck. If the current element is different from the candidate, we're going to decrement the counter. So the counter was 2, now we're going to decrement it by 1, and now it's at 1. So at I equals 3, that case is struck again where the current element is different from the candidate, because our candidate is 2. So we're going to decrement the counter, and we're at 0. And now, since we're at 0, we know the next step is going to be this one. So at I equals 4, the counter is 0, so we're going to set the current element as the candidate, and we're going to increment the counter. So at I equals 4, the element is 1. We'll set that as a new candidate, and our count is going to be incremented by 1. At I equals 5, we have 2, and then we're going to hit this last case. If the current element is different from the candidate, we're going to decrement the counter. Decrement the counter because 2 is different from the candidate, which is 1, right? Finally, we hit I equals 6. Now the current element is 2. The candidate is, we're going to set a new candidate because our count is 0 from the previous iteration. If our counter is 0, we set the current element as the candidate, and we're going to increment the counter. The candidate becomes 2, and we increment our counter by 1. And now we terminate the loop, and our candidate, by the end of this, should hold a potential majority element since we've iterated through the array. And it does. We know from this, even just counting this by ourselves, 2 appears 1, 2, 3, 4 times. And there's 7 elements in the array, so that occurs more than n over 2 times. We can confirm that with our majority target, which is just n over 2, 7 over 2, 3.5. As long as the candidate appears over greater than 3.5 or greater than or equal to 4 times, then we can just return that candidate, and it does. So there we go. Here is the code for our Boyer-Moore majority vote algorithm, which solves the problem in linear time and in constant space. So we'll start off with initializing our candidate and our counter, which was step 1. Next, we're going to iterate through the array inside of this for loop, and we're going to check for the following cases. If the counter is equal to 0, we're going to set the candidate to this current number. Next, we're going to check if the number is equal to the candidate. If so, we're going to increment our counter by 1. Otherwise, it's not the same as the candidate, so we're going to decrement our counter. Finally, by the time we're finished iterating through this array, our candidate will hold the potential majority element, and we can just return that candidate. Let me run this. Passed our test cases, now I'm going to submit it. Awesome.